Hello everyone. Today I'm going to show you how we can solve the 2D triangular element by non-linear case. So here I have a 2D element, and the question is find the K matrix, and we have three nodes. For the node number 1 is minus 1.5, the point on x direction, and 1 on y direction, and same with here we have two the element number 2 and element number 3. Each node has x and y direction or displacement of this element. So, and the t is 10 nn, and the Poisson ratio equal 0.25, and the elasticity of steel equal 200 gigapascal. Okay. However, so first of all, the K matrix equal A time T time B transfer time D matrix time B matrix. So first of all, let's solve step by step. I will find A, the area of shape. A equal half determined for this one, 1 1 1, this is constant, x1 x2 x3 y1 y2 y3. Okay, so just substitute your values and find the determinant of this matrix. X1 is minus 1.5, x2 is 1, x3 is half, y1 minus 1, y2 equal half minus half. Sorry, this is here minus. Okay, and the node 1, and for the last one is 1. Calculate is by using your calculator. So the final result equal 0.75, okay, meter square. Then go to find the B matrix. B matrix equal the D1 for derivation of dx 0 0, D1 for derivation of y, D1 dn1 for the dy, and dn1 for the dx. This is for node number 1. Okay, then go to here we have matrix. Okay, node number 2 dn2 dx 0 0, dn2 dy, dn2 dy, and dn2 over dx. This is for the node number 2. Same with node number 3. Sorry, I don't have enough space. So this is the general equation, or sorry, general matrix for the B matrix. So now actually I make it easy for you, just to make it as simple, because I have 2D elements, and actually the rules now is come from derivations. So let's, to make it easy, here I use the derivation each node for the x and 1 on the x and y direction. So now I can make it this one, the dn1 on the x dx derivation on x, call b1. The node 1 for the dx equal c1. This already will go c1 b1. Same thing with node number 2, but here I will give only the number 2 for just for to mention I am working on node number 2. This call b2 c2 b2 sorry c2 and b2. Same thing with the node number 3. I will rewrite again to make it easy. B matrix equal b1 0 0 c1 c1 b1. This is node number 1. Node number 2 b2 0 0 c2 c2 b2. Node number 3 b3 0 0 c3 c3 b3. This is the B matrix. So now, how can I find the value of B1 and C1, C2, B2, and C3 and B3? Let's go now. Let me to change the color. B1 equal y2 minus y3 equal minus half minus 1 equal minus 1.5. This is the value of B1. C1 equal x3 minus x2. Just substitute the values of x and y of your element. Half minus 1.5 equal 2. So that just substitute your value for B1 here in this matrix, in this element, and C1 equal 2 here, and same here, B1 here also, same value. Okay, let's go to B2 and C2. B2 equal y3 minus y1 equal 1 plus because I have minus 1, so it will be 1 plus 1 equal 2. C2 equal x1 minus x3. Therefore, minus 1.5 minus 0.5 equal minus 2. Same, substitute your values here for B1, B2 and C2. Go to B3 equal y1 minus y2. You see, I don't have any y3 because it's actually derivation. If you check the criteria shape, okay, minus 1 minus 1 equal minus 2. C3 equal x2 minus x1 equal 0.5. It will be minus with minus, it will be positive. It will be positive 1.5 equal 2. So I find the all values for the B matrix and just substitute your matrix only, that's all. Just substitute. Besides that, sometimes actually you want to find the alpha value. If you go to the derivation of triangular 2D element for the special case, there is the element A. Okay, I will not solve for you how you can derive actually, but some reference use C matrix. Okay, C matrix is equal inverse 1 over 2A, A1, B1, C1, A2, A3, B2, B3, C2 and C3. Here I use only B and C, this example, but for the A1 and A2 I will just write for you how you can find A1 and A2 and A3. So let's start with A1 equal x2 times y3 minus y2 times x3. For the A2 equal x3 times y1 minus y3 x1. For the A3 equal x1 times y2 minus y1 x2. This I give to you extra for you, maybe because some students they don't know how can solve A1, A2 and A3. I just direct rule for you. So let's go back to our example. Now I already find all values of B matrix and just substitute the values in the matrix. So the B matrix equal minus 1.5 This is your matrix, B matrix. Then go to find the D matrix. D matrix is E over 1 minus Poisson ratio, 1 Poisson ratio 0, Poisson ratio 1, 0, 0, 0, 1 plus Poisson ratio over 2. E you have to E is 200 gigapascal time 6, okay, and the Poisson ratio already given is 0.25, and just substitute your values here. Just all you need the Poisson ratio here. Poisson ratio equals 0.25. Okay, and make it as simple. If you want to make this part simple for you, it depends on you, no problem. And after that, find the multiply B matrix with D matrix. Okay, you will get the value, and actually you will get a new matrix. Okay, and then take inverse, or actually sorry, transform for the B matrix, because the K, actually our example asking about how you can find K matrix. I will rewrite the rule T times A times B transfer times D matrix times B matrix. D you will get from here, and this is from previous slide. Just multiply both of them. Okay, you will get matrix, and transport this matrix for the B. A already you will find it, and the thickness I think it was 10 nm. It will be 1.01, and then you will get the K matrix. So the K matrix, it will be equal 6 times 6. Your matrix, it will be a big matrix for K. It actually depends on how many nodes you have. So here in this example we have a 2D element. Okay, it's actually not depend because we have 2D. No, it's depend on the node. Actually, we have in this example actually a triangle and it has 3 nodes. But if we have 4 nodes or 5 here in the middle, for example, or yeah, let's assume the first in the middle. Sorry, let me to redraw. This is our element and we have 3 nodes. 3 nodes you will fill or actually will go on with the same solution, and I mean you will get a K matrix is 6 by 6, but if we have a node in the middle, for example, your matrix, K matrix, it will be 12 times 12. Okay, maybe I can show you in the next videos the full solution with the numbers and with whole solution. Actually, I can show you in the next videos. So actually the elements of K matrix is depend on the node. Whatever you have 3D or 2D, doesn't matter, it just depends on the node, because we solve the element by element. For example, here if we take this example, this triangle, here this one is the element number 1 from, let me to make it in the new slide. Actually, this one is one element only, one element, but for this one we have 2 elements, because in the finite element method take the element from node to another node. From node number 1, let's assume this one node number 1, this is also node number 2, this is node number 3, okay, this is node number 4, and this is node number 5. Actually should be the like this direction, but just I'm explain. Actually this is a wrong things to give the number of node. So I just explain for you. This is the first element or element number 1 from node 5 to node number 1, and here we have second element from node number 1 to node number 2, element number 3 from node number 2 to the node number 3, element 4 from node number 3 to node number 4, and last one is element number 5 from node 4 to the node 5. Okay, if we have also the node here in the middle, so it will be, this is the element 1 and this is element number 6, so we have 3 elements. So that's all, and I will show you the full example in the next videos with the full solution, and it will be easy for you. So thank you so much for your kind attention and watching.